Welcome back, my slippery salamanders. Today we have another episode of Fun with Foos. I'm your host, Mr. Foos, and today we'll be covering homework number 4. I know we're getting close to exam day. I know it's stressful, but after we get you well prepared for this exam, you're going to be covered in some post-win Gatorade, like every coach after a football game, and I imagine that it'll be pure excitement and joy on your end. But first, we gotta have an hour of study. You're not you're not there yet. So I think I have. Let's just swap over. Oh, actually, I'm gonna get rid of this guy too. Yes, sir. Okay. Normally I add that in post production. The little Fun with Foos logo. What am I up to? I realized that I have not really liked the energy that I'm providing. It feels a little stale. I'm getting a little monotone in these videos. So I think I'd like to invest a little more in the fun aspect. I haven't asked for like formal improvement on any of these videos, but if I were me, I'd be like, man, for some some guy saying this is fun, it's not actually that much fun to be doing our homework. So I'm trying my best. I'm gonna try to bring a little more energy. Okay, I already have the draw tool. That rookie mistake. But getting into our econ, we can start off with number 1. Suppose the price consumption curve. Okay, as the price of good X changes, we covered that in the last video. Oh, get out of here, Mr. Adobe. Okay, and I think this homework is very similar. We're covering income and substitution effects, which I don't really have like a conceptual like 2-second spin on what it is, other than like these are what goes into you making decisions. But a lot of it pulls from like the demand stuff we did last time on homework 3. So hopefully it's not too much different. So I am going to say that this is my price of X, and this is what it looks like when my price of X increases. So the price consumption curve is vertical, which looks something like that. I've been trying to improve on, I think that's a little more vertical than what we used to be outputting. I also noticed, maybe you can tell, the light up there is super terrible. So I'm coated in this like mid 2000s like blur all with mediocre lighting. But the price elasticity of demand for good X is 0. So that would be the dx dpx times px over x. So I would assume that this thing is never 0, but we're looking at this dx dpx. So as I increased the price, my x did not change. So the price of x increased, So going from this thing to this thing, maybe I'll just say decrease, because I normally like to think about it going outward. But the price of X decreased and X stayed the same. So I think that would mean that this derivative is in fact 0, that this price of X had no change on X. So the price elasticity of demand is in fact 0, because this thing is 0. And then the cross price, do a little crisscross cross price, elasticity of demand with respect to the, okay, so what am I looking at? I'm looking at dy, because it's asking about good y with respect to the price of good x. Dpx is positive. So I would make the same assumption again, that this thing will be positive because like prices, and we're assuming we're not on a corner solution, that we're really just like honing in on what this derivative means. So as the price of X decreased, my Y did in fact increase. So interestingly, the cross price is positive. I would think that this would be negative. Wait. Okay, I had a little brain fart. That this is excellent. That this is not positive, which means that this would be a false statement. I forgot that we were in a void of true or false. But okay, well, so we do agree this is true, this is false. So only statement 1 is true. Bada bing, we got A. And I think this one's going to be basically the same problem, but this time with the income consumption curve. Wink. Okay, let's get the same axes. They're always just half a Minecraft block. And we are going to write X and Y. And I'm going to get my 2 levels of income. And we know these are the steps for doing price consumption and income consumption. You always just make the slow format. But the income consumption curve is horizontal, which means that it looks something like that. Steady hand, steady hand. Excellent. It's still a little bumpy, but it's okay. It's looking better. Every day we're on the come up, and that's all that matters. When you're putting in the hard work, you're seeing improvements step by step. That's what I'm looking for in life. But is asking me the angle curve for good Y. So the angle curve is if I just put Y in income on this. So it's saying that it is vertical, that for any, I guess Y would not change with respect to income. So is this true? I do believe it is true. So what I'm seeing here is that as income is rising, that my Y is staying on the same level. So Y did not change even though I changed my income from this budget line to this budget line. And I believe this would match up with this graph where, even though I'm increasing my income in the upward direction, my Y is staying the same. Like we're just at the same level of Y. So I do believe in that one. And I think this is just the same as saying dy di. If you're interested in the math approach, I kind of like the graphical approach. It makes a little more sense to me rather than just like having math in a vortex. In a vortex. Maybe that's right. In a vacuum? Yeah, maybe the vacuum is what I'm looking for. And that the income elasticity of demand for good X is 0. So I think that's the exact same thing. So we're asking dx, di, we're assuming income and X are also positive. So we're really just interested in this derivative. And as my income increased from lower budget line to top budget line, my X did increase. So as income increased, my X increased, which would mean that it is positive. So that it is not 0, it is positive. So we are only going to go with statement 1. Nice. Okay, so for number 3, we got Mr. Manuel, and we are given a utility function, and we're asked to find the elasticity of demand of good X and the price of good X. So I'm just highlighting like key terms here in order to tell me that the game plan for this problem is that I want to find this elasticity formula. Wait, dpx, there you go. Because we always do the little flippy floppy with our elasticities. So like when p of x is on the bottom, I just flop them up there. And I think all we're doing here is, I'm not actually given any prices in this problem. So I think we're just going to treat it as a normal demand problem where I'm going to do our MRS equals to MRT, and we're just going to cook from there. So the MRS marginal utility of X is going to be 1 over X. The marginal utility of Y is going to be 3, which would be 1 over 3x. That's our MRS. And then we're going to equal that to the MR tizzles mixed with PY. And then we're going to get 3x px. Sorry, that's a little wank. Okay, there you go. And 3x px equals py. And I think I just want to isolate for x here, because then we'll have an awesome demand function. So we'll get py over 3px. So I believe this is the demand function for x because it doesn't have anything in terms of y. So we've checked all of our boxes there. And now I want the derivative of this thing with respect to the price of x. So how do I go about doing that? I would probably rewrite this as 1/3 py px to the -1. And then I would go 1/3 -1/3 py to the px to the -2. Just because I'm I'm really lazy, and oftentimes it will get messed up in my derivatives. So I think that's the best way I would tackle this, is to take something in the denominator and just write it with a little negative exponent. And from there, we have this derivative. So we have -1/3 py px to the -2. And then we're multiplying it by the price of x over x, where x was the py divided by 3px. And I believe what this will get us is hopefully some canceling out, but I'm not I'm not entirely confident in that. So if I were to divide this thing, then I would be multiplying by the reciprocal. So I'm just working on like this piece right here, because I know I know what the left side looks like, but I do not currently know what the right side looks like. So this would be px times 3px over py, which would simplify to 3px squared over py. Okay, so this was that multiplied. So I am going to cross out that guy because they're multiplied to, oh no. Oh, okay, we're back. And that guy's gone. He was trying to sabotage the plan. The prices of x are also gone. I keep hitting the button. What am I doing? It's because this is just +2, this is -2. It's like if we used our multiplication rules, then 2 minus 2 is just going to be 0. And 3 and 1/3 also cancel. So all I'm left with is everything canceled, so I just get a -1. And this is going to be pretty good. So this means that my oh god, okay, stop. No, that's the wrong zoom. Okay, we're back. I am really fumbling with the technology today. But this is our elasticity. And what this means is that a -1, I am fumbling all over the place, is for every 1 change in the positive direction, I would expect an equal change in the negative direction. So if I were to decrease the price of good X then by 12%, then I would expect an equal and opposite increase in the demand, which would be D increasing by 12%. And typically, like, elasticity of demand is going to be negative, assuming that the law of demand holds. I guess I didn't have like any, in a Cobb-Douglas, I think they're going to hold, so I guess I did have to in fact solve that. But yeah, that is how I would do number 3. Serena Williams, her preferences for good X and Y are, okay, now we got, they're throwing me the Cobb-Douglas. They were hearing me talk about it. Use the elasticity of demand. Oh, brother. Okay, so once again, good Y and income. Excellent. Okay. So I think we're going to need the demand function for good Y, because I don't know if I have any. I think it's going to be a normal good, but I can't tell you by how much. So I'll write out that we're looking for this formula is, I think, the game plan. And let's just get cooking, I think is is all we gotta do. So this is going to be 1/3 x to the negative 2/3 y to the 1/2. And in the moment, I'm thinking it'd be funny if like whenever I do these lame math compilations, that it'd be funny if I like did a time lapse and just had like little chipmunk Robert talking over it. Whenever I think chipmunks, I think Alvin and the Chipmunks, and that always puts a smile on my face. But okay, so I think that's our MRS. This thing is going to come down. That's going to go up. So we're going to get y2 2y because the 2 will come up over 3x, I think. Okay. And then equal that to the price of x over the price of y. And from there, we can get a little cross multiplication equals to 3pxx. And since I want my y, I'm going to isolate for x here. So I'm going to take this, I'm going to divide by 3px, get rid of that, and then we get our x. Oh, actually, I could have just, here, well, I'll do the old cool strategy that I learned last time, was that if you just leave it as pxx, then when we go income equals, and then pxx is just going to be 2ypy divided by 3 plus pyy. And from here, wait, okay, so we have 2/3 of a pyy. So ultimately we have 5/3 of a pyy. I think, because I'm just treating this as 3pyy over 3. Hopefully that makes sense. I'm kind of speaking in like math jargon right now. I'm like a little sage speaking to myself. But I'm just going to combine fractions here is all I'm doing. And I think I would get I equals this. And from here, I want to isolate y, correct? Yes, because I want to take some derivatives with y. So I'm going to get y, I'm going to multiply this thing over, so get rid of that. And then I'm going to divide by 5py. And then we can get rid of that guy. And from there, I think we have what y is equal to. So if, oh, luckily, dude, this derivative is going to be awesome. So if I just take the derivative of this guy, then I think all that happens is the I drops off. So we're going to get dy is equal to 3 over 5py. And then we're going to multiply by I over y. Okay. And then I think I'm a little scared that this is not coming out to be a nice little cancel. So let's go consult the answer key and see where I might have gone wrong. So 3i 5py is definitely good. And then what did they do? Whoa, holy mo. Oh, that's why. Yeah, I'm a stinker. I am quite the stinker. Okay, so that's a good tip for you. If the ULA is getting tricked, and maybe I'll go with I always feel a little insecure when I have these moments of of not knowing to go where the problem is. But maybe it's actually a better learning tool if I reveal the behind the scenes of me being an idiot and going to consult the answer key. So good y is, we're not like actually taking y, we're taking what we defined as y, which was y is equal to 3i over 5py. And I kind of just learned there that it should always cancel out, I think, is like the the name of the game, is that it should just give you a number. So if it doesn't give you a number, then that's probably a bad sign. And multiplying by a reciprocal, this is going to be 5pyi over 3i. I cancels, and we're going to get 1 again. Because 5/3, 3/5, the py's cancel. Yeah, everything cancels. Okay, so we got a positive 1. So elasticity, oh, I think maybe if you're fancy, you can have like a subscript of like which good you're going for, and then like what demand or like which elasticity is. Maybe that'd be elasticity of yi. I might be full of garbage, to be honest. I don't know if that's proper format, but it makes sense to me. So elasticity of y with respect to I, we found was 1. So if we increase by 10%, then that means I have a positive relationship, and we're going to have an equal change. So if our income increases by 10%, then we're going to have a normal good, and we're going to have a equal increase by 10% in the demand function. Ray, what's an interesting character named Ray from Star Wars? That's what my mind would go to. So Ray has a quasi-linear utility function of the form blah 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 blah. Dude, are you really making me do another cross price? Yeah, okay. So we need to find the demand for good X with respect to Y. But it's interesting, it might not nicely cancel, because this one seems to have a good amount of answers that don't just cancel. All right, let's get started. So this is going to be 1/2 x to the negative 1/2 divided by 1, and we're going to multiply by pxx. So wait, so this would be 1 over 2x to the 1/2. No, I'll probably nah. I don't know how I want to write it, but let's get our MRT equals to MRS. And I'm going to get that py is equal to px to x to the 1/2. I think we're good there. So from here, I can divide by 2px, and we get rid of that guy, we get rid of that guy, and then we square everything. Uh-oh, we're getting a little messy. And then get rid of that guy. So our x is equal, our x is equal to py over 2px squared. So this does look like a good demand function, but I'm interested in the cross price elasticity. So I'm looking at dx dpy times py. It seems like this homework is a lot of just understanding the conceptual derivatives, which I would agree is is a valuable tool, but they're spamming this. They're making sure that it is drilled into the back of our head, and that we're never going to forget it. I just went to an interesting pedagogical seminar that I didn't know this stuff existed, but we had an awesome dude from Cornell, and he came in to talk to us about all the little stinker Cornell students and whether or not they remember their econ homeworks from like 3 years ago. And he presented us like pedagogical research on like how people retain information. But back to getting serious. If I add a little too much fun, then these videos are going to take like 3 hours. So we gotta keep a nice balance. But so the dpy, I think how I would maybe write this is py squared over 4px squared. And sorry, that 2 looks a little terrible. Oh well, hopefully that looks like a 2. Remember that 2 squared, like in the denominator, would become 4. You got to apply the 2 to everything. And from here, I would bring that puppy down, I think. So I would say 2py over 4px squared, which is the same as saying py over 2px squared. And sorry, that this is the derivative that we are interested in. This I'm realizing that it's kind of looking like hieroglyphics on the board. And from here, I need to multiply it by py over, and then make sure we plug in what x actually was. Otherwise, the people will get very mad at me. Oh my gosh. And then I want to write the simplified version because I feel like it will be easier to combine. 4px squared. Okay, the same reciprocal little thingy. So this is going to be 4px squared py over py squared. So get rid of that. And the px squareds are going to disappear. The py is going to disappear. And then I'm just left with 4 over 2, which is equal to 2. And the answer, hopefully, is number 5. Is that A? It is A. Excellent. I don't know. I think elasticities can come in I don't think it has to be a number, because sometimes I believe a question is possible where like they'll tell you the price of X and then it'll become a number. And the problem, like it might solve to like 4px, and from there you'd plug in like px is 5 or something, you get like 20. But I think everything felt pretty smooth there, just like the same format of I would just practice this. Like I can assure you elasticity stuff will be on exam number 1. That's a spooky event. That's like the the judgment day of ECON410 is when everyone realizes that they are not gangsta enough to perform on the tests, and then the help sessions, they become quite lively. People want some help after they realize that they can't just ignore this class and get an easy 100 on all the tests. But okay, oh no, this is quite disgusting. Oh brother. So the income consumption curve. Do I really have to? Okay, I think we can use some arrow math. So I don't think this is as bad as I once thought at initial glance. So we can get our x, y. This is going to be a long problem though. These are the worst when you have to check all of them. The income consumption curve, although it did give me just a true, so luckily I only have to find one of them. The income consumption curve is upward sloping. So it appears that as my income increases, my x would decrease because this is a negative number. So like as I increase my income, x is getting smaller. So we're at least like right here to like right here or something. And y gets bigger with income. So that would check out. So no, we are not upward sloping. We are in fact downward sloping at the steep downward slope. So that one is not true. And I think arrow math is the saving grace here. This would be terrible if I if I solved it out and then like took the actual derivatives of everything. The price consumption curve is downward sloping, maybe. So the price consumption curve, x, y. Maybe I should just do lower cases for y's. I think that's why I was watching some Khan Academy. My boy Khan is still, he's cooking for me. Even to this day in college. I think I actually like him more. I thought he was boring in high school, but I'm coming around on Khan, and I think he just makes lower cases for y, because doing the two separate thingies is annoying. But as the price of x changes, so let's just decrease the price of x like we always do. And I'll write that the price of x went down, just to remind myself. So as the price of x goes down, I would expect my x to go up because the denominator is getting smaller, which means I'm dividing by less. And for this, if price of x went down, then I am decreasing the size of this denominator, which makes this term larger. But since I am subtracting by a larger amount, then y would go down. Oh, we are having a little bit of a traffic jam. Okay, traffic jam on 40. That y goes down here. So how do I draw that? My x increases and my y decreases. Something like that. We have a downward. Oh my god. That was the most like blatant. I'm sure there are people on the homework that do that like their graphs do not match up at all. But since you're too lazy, like if you've already spent 3 hours on this problem and you hate it, they just like trying to make it connect and maybe like add some eraser shave marks or something to to hide your tracks. But I think this one is in fact true. Once again, I have the power of the answer key, and I know that B is the correct answer. Proper form probably would be to check all A through E, but that would take a lot of time, and I don't have the time. I am trying to make sure that you do not watch a video for 8 hours. We're trying to keep it palatable for all people. It says to use the little chart, so I'll make sure to use the chart. Consider the figure below, bundle A, blah, 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 blah. Okay, determine which one is false. Remember, honestly, this is probably the biggest vocab piece on. You gotta remember the true or false on these problems. So what's happening in this thing? We have like a compensated budget line, that we got the substitution effect and the income effect. And just like a little teaching moment, the substitution effect is always A to B, A to B. Sorry, the handwriting is kind of taking a hit here. I don't know why. I just turned into a little monster, a little gremlin with terrible handwriting. But this is our normal setup where the substitution effect is going to A to B and the income effect is B to C. So the cross price elasticity of demand for good Y with respect to the price of X. So what I would say is as price of X, let's say it decreases. No, it increased in this problem. So as the price of X increased, so as I went from there to there, then from A to C, the cross price elasticity of demand. Let's go investigate. Answer key. Scroll down a little. Scroll down. So it does in fact go up. The substitution effect. Okay, I like how they did it. As the price of X increases, total effect for Y is an increase. Okay, so I like how they did it. That's what was going through my head, was that we're looking at the total effect here. So the total effect is that, why do I keep getting this a picture when I hover this thing? What does it say? A picture containing diagram. Interesting. Demand for good Y with respect to price of X. So our Y went up, which would mean that I think that this means that they are substitute goods, right? So if the price of like peanut butter, no, what's a good substitute? If Coke and Pepsi, if Coke and Pepsi, so the price of Coke goes up, then I want more Pepsi because Coke sucks now because it costs a bunch. So yes, since the price of X went up and my Y went up, then this means that this is the total effect of what happened, and it would be a substitute. That this does check out. So We're looking at which one is false, though. The income consumption curve slopes upward. So this is the, let's make the little chart, because I've been skimping on the chart. So price of X went up, and I write X, Y, boing, and then we get that cooking. And then we have substitution effect and income effect. Holy moly. I don't even know what that is. It just came from the outer worlds. Income effect and total effect. So ultimately what happens is substitution effect is always the same. So if the price of X went up, then I know that people want less X and more Y. That's always given. And for any table problem, you can complete it like that. In this case, we saw that from B to C, my X decreased and my Y also decreased. And my total effect from A to C, right? I forgot to write that the total effect is from A to C. That's also, I guess, an important thing to know with the table is that my X went down and my Y went up. And that would match up with our little table right here. Actually, some people call it the chart. I was impressed by at our ULA meeting yesterday. We were gung ho about calling it the chart and using it as a verb. I was unfamiliar with how much people love calling it the chart. But maybe I should speed up. I'm realizing that I'm spending some time on this. The income consumption curve slopes upward. How would I do that? So I would make an income consumption curve, and I would say that my purchasing power went down here, so my income effectively went down. So let's imagine that my purchasing power went up. Then it would do the reverse here. So if I got more, like I'm just here processing what I'm doing, I am flipping these. And like what I know is that when this arrow matches with this arrow, then that means it's a normal good. That's an interesting takeaway that I would probably push if you want to take something away from this video. Is I always write the purchasing power over here, like with respect to the price, because if my prices go up, then like I effectively feel poorer, and that's what this purchasing power thing means. And just remember that if they go in the same direction, then it's a normal good, and if they go in opposite directions, this purchasing power and this, then it's inferior good. And I know with two normal goods, if the price or if my income goes up, then I'll buy more of both of them. So it should, in fact, slope upward. The price consumption curve as the price of X changes. Oh, brother, dude, these, you're giving me all the graphs. So as the price of X changes, I guess we already have the price of X changing. It slopes downward. Oh, man. So I know that my Y went up and my X went down as my price of X increased. So if I go from here to here, then my X should go down and my Y should go up. And then I just connect the two. And sorry, this is really small, but as my price of X went up, the Y went up and the X went down. Yep, that checks out. So it does, in fact, slope downward. We're good on that one. The income effect on good Y is stronger than the substitution effect. I think that one's false because the substitution effect is what carried this total effect arrow. So like, even though we have a mismatch in voices here, MSA likes to call them the voices of your substitution income effect. And Since ultimately we chose to go up, then that means that my substitution effect voice was more impactful. So I would say that this one is false, that it is not true. And 7 is in fact D. I probably would have, this one is actually the easiest to figure out. Like if I was doing it for time efficiency, then the graphing ones are probably the worst. And you can tell that one from like 2 seconds of after you make the chart, you can, you can figure it out. So maybe it's some meta-analysis that I would have started with D if I were you. But that requires a little bit of wisdom to know. Suppose Lisa spends all of her money on rice and beans. Give me the beans. When the price of beans increases. Okay, so price of beans increases. And we got rice and we got beans. And then we got our substitution effect. And this is what the chart is just like making this format every time that you can just write it out. And sometimes I might even like make more grid lines. But this is what the chart means. And you can pretty much always write it like this based on whatever they give you. Sometimes you'll have to pick though, like it will tell you that the price of beans changes. And sometimes you just kind of have to arbitrarily pick like up or down. But in this case, it told us that the price of beans increases. So I'm just following along with what the problem tells me. So we can always fill in this, that the price of, or the substitution effect, we're going to go away from beans and towards rice, just because that's how it be. The substitution effect's a universal constant in the world of the microverse. The income effect. So my purchasing power went down because this one went up. And we know that rice is an inferior good. So this will go up because those arrows should mismatch. So I definitely know that that is going up. The consumption of rice will rise, which is 8B. That since we have 2 up arrows, that's also got to be an up arrow. And that one's pretty simple. I guess D and E were kind of baiting you on, maybe you're looking at beans or something and you got confused. Because we didn't really have a question mark on the chart yet. And question marks are an interesting lesson that I can provide if it is not on the homework. Assume which of the following statements A through D are not necessarily true. Okay, jeez. What is happening? They just filled me with like so much word clutter. The price consumption curve is price of X changes is upward sloping. Okay, let's get that graph going because I do know how to read that. I do know what that means. That the price of X, let's just say price of X decreases because that's how I always like to roll. And you too can roll with price of X decreasing if you like my style. Which is following is not necessarily true. So it is upward sloping, which means that we have something that looks like this. Which means that as the price of X decreases, my Y increased and my X increased. And we can actually make a chart from this. So I think that's what they advise is, let's say my price of X decreased and, this is a good example of one where it didn't tell me how to change it, but I just arbitrarily chose and we got to follow it through based on how I chose to do it. And then let's write, nope, wait, there you go. Income effect and total effect. Here you go. So this will go up. Wait, yep. This will go down. I am not given anything about the income effect, but this definitely goes up and this definitely goes up. And my purchasing power went up because I effectively have more monies because the price of X went down. So what I do know is that since this one went down and this one went up, this necessarily means that this one went up, which means that I conclude that Y is a normal good, because the purchasing power and this arrow go in the same direction. But so which of them is not necessarily true? Not necessarily true. This is definitely true. The law of demand is that the price of X went down, total effect went up. So that's definitely true. And remember, the law of demand is we're looking at the total effect, what actually happened. So in these charts, like the total effect is like, if I said I buy more X, like that's the vocabulary signal of what we're talking about. I'm a little skeptical on this income effect piece. And because this could be income neutral or even income down. And I believe what this is saying is, this is kind of the tricky one, and this is the awesome question mark that I was talking about. So with the chart, you have to be knowledgeable about the magnitude of these arrows. And by magnitude, I mean how big the arrow is. So when I analyze this X category, like what I see is this up arrow for the substitution effect is definitely up, and this total effect is also up. But what if I told you that this total effect was just like a little baby up? And the reason why it's only a little baby up is because I added the income effect went down some. So actually, I'll rewrite it like this. It's like, this is the substitution effect. This is the income effect. And then what if, like, what I'd be left with if I combine these two arrows is like a little baby up, because I got rid of this chunk of the up. So it still goes up, like it still satisfies, what I said that it went up, but I couldn't tell you whether or not this was, it could also be up. Like, if I had one up arrow for the substitution effect and another for the income effect, like our total effect would be super up. What's a, there's a game only up, and there's also a movie, Superman, that went through my head there. I watched the Superman movie last week, and I thoroughly enjoyed it. It made me proud to be a human. But I think the answer is going to be B, is that we don't know about the income effect here, and therefore we can't automatically know that it's a normal good. But the Superman movie is very good. I like I like Crypto. Crypto, the stupid dog, is my that's my MVP character. That movie is like super on the nose, but it's a feel good movie. It makes me proud of of where life is going. But okay, so we have all of our normal conditions, and we're evaluating the following statements. Oh, brother, okay. If the price elasticity of demand for a good is 0, then the good must be an inferior good. So let's do that. So let's say that the price of X went down, and let's take X, and I map out my substitution effect, income effect, and total effect. I'm probably going to have to super speed through these long forms just to not take too much time on this video. But this is guaranteed to go up. My income effect, I don't know. But I do know the purchasing power went up, and my total effect, but it said that it's 0. So that means that this is going to be no change, that I did not buy anything, that this must go down to make this a 0, that like since I had an up, I need to have an equal down to get the 0 there. So I do believe that that would mean that since the purchasing power and the income effect arrow are mismatching, that this would be an inferior good. But if the price elasticity of demand is negative, so let's get same situation going, but this time it's nope. So if it's negative, then it would mean it went up, because this means that follows the law of demand. If the price elasticity of a good is negative, then that means it follows the law of demand, that as my price of X went down, I would expect this to go up. Then the good must be a normal good. So once again, this is the same question mark case, where a lot of the times we'll literally just put a question mark because it relies on the magnitude, that like it could have been that this is up and it would be a normal good because it's matching the purchasing power, but it could also be down at a small magnitude. It could be a zero. Like, I don't know. So we cannot be sure that this is normal good. We have a question mark here. So ultimately, I am going with only statement 1. It's interesting that only the statement 1, like on this whole, sorry, my bad, team. we are locking in A. It's interesting that a lot of them were like only statement 1 is true, so you only had to like do half the problem. So as per usual on the long forms, I will just highlight the things that I would pay attention to and kind of write out a game plan for y'all, and then just go to the answer key and kind of pray that you guys can figure it out on your own. I know the long forms are probably where like people have the least amount of confidence because you have to do it yourself. But it takes a lot of time to work through these, and I don't think you guys get the most bang per buck out of watching me do it. But Jan's demand function, so we're given some demand functions, predict how the quantity demand, blah, 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 blah. I see that it's changing by %. So whenever I see this % thing, I'm probably thinking that I need to use the elasticity formula, which we just did a bunch of elasticities up here that are going to be, or no, this one, number 3, with Consignor Manuel and Serena. So I would copy the steps there. And what is part B asking? Rachel eats eggs and toast for breakfast. So this is a perfect complement. Yeah. And predict what will happen to her consumption of eggs and toast. So I think in that case, wait, where did that go? Are these the same by ceteris paribus? I feel like that's a that's a specific term that I think means the same demand function, but I'm not entirely sure. So I'll go see, but I think basically what that's asking for is the same, like go find the demand function. Okay. So as I expected, the long form A, it's just the same, find the demand function, take some derivatives, blah, blah, blah. Interestingly, why'd they take the dypx? Okay, yep, so it says, and his demand for good y. So that's why they do both, that you just had to make sure to find the demand for both functions. And this looks like a lot, but they just did perfect complements. We know how to take the demand, or at least hopefully last homework we learned how to take the demand of a perfect complement. We plugged into the income statement, blah, 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 blah. Income is equal to this thing, the elasticity. Okay. I over, so this was E? Oh, okay, ET. Ceteris paribus. Okay, it's not the same thing, but I'm just an idiot that the demand function is given to you whenever you're given the ratio of in a perfect complement, that is the demand function. So I think, I don't know, it looks pretty standard to me, and I guess it came out to be 1. So if my income tax cut increased my income by 5%, then I would see a 5% increase in both my egg and toast consumption, assuming both of these are normal goods, I think. meaning that for a 5% increase, consumption, should rise for 5%. And then for this one, I just want to make sure that we're good. So these are kind of like multipliers. I view them in my head as like multipliers. So if they gave me 20%, then like I would multiply that by 2, and that's why it's like 40%. And this one was 3, so like we saw it 3 times as much, 20%. And that's a pretty common way of doing that. And I'm seeing a little chart here. It actually says to make a chart. So if I were doing this, Mr. Michael, whoa, we get a Michael lore drop. We have 2 ULAs named Michael. Maybe this question is built for one of them. But blah 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 blah. After the price of noodles rises, so I would just make the chart. I don't really see why this one would be too crazy. Why does that go down? Because it tells us that we buy the same quantity of noodles and less cereal. So that looks, I don't know, that looks pretty normal to me. So if this went down, like we're automatically given this, and you can, piece together the income effects from there, similar to how we did in the multiple choice. And from here, we are given a graph. So we're going from A to B to C. And I haven't mentioned the compensated budget line. This is one of my favorite lessons to give. So I'll make sure to give a little lecture on how and why this is important. So when you're graphing these problems, like the key is that I want A and B to be on the same indifference curve, and I want the slope of budget line compensated to be on budget line 2. And the core takeaway of why we do this is that we can separate the 2 effects. So like the budget line compensated, what this is it's kind of saying like the amount. So like this is always when we change up a price of one of our goods, and we're kind of seeing what happens to the effects and like our total effect. But what the budget line compensated does is it kind of simulates like previously what would have been the case. Like if I wanted to be on the same indifference curve as the previous situation, that like I would have to expand my income, because like the ratios have changed, but I kind of need to like expand my income at this new slope in order to reach like what the other indifference curve used to be. And like if that didn't really make sense, you can just have the buzzline word of you need the compensated budget line to separate the substitution effects and income effects. And you can also just commit to memory that A and B will always be on the same indifference curve. C will be on a different indifference curve. And that B will always lie on this compensated budget line, which is the new budget line. It is the new budget line slope, and then you just like scooch it out or in depending on whatever you're graphing. I think typically you'll be scooching the compensated budget line out. And I guess just like a little tip is that we always just like dot the compensated budget line just to make it more easy to read. What else would I take note here? They found these points by taking the chart. So typically you'll make these charts, or you'll make the graph based on the chart. So like with noodles, for example, from A to B, I know that noodles should go down, which it did, and that the cereal should go up, which it also did. And like the income effect, it goes up. So my noodles went back up from B to C, and that my cereal went down, which it also does. and noodles stay the same ultimately. So like that's why it's on the same level, but the cereal went down. So like from A to C, I am buying less cereal. And I think these graphs are generally pretty cool and fun. They're less fun when it doesn't line up. So a common scenario that you'll probably have is like you'll draw this compensated budget line like pretty generically, and it like probably won't line up how you would expect it to. Like it won't be perfect and illustrate what you're trying to illustrate. So you'll probably like fudge it a little. There's definitely been times where like, I don't know, if I generically drew that like my B was over here, that like I would be like, and then you just like kind of fudge it, and then yeah, dude, B and A are on the same indifference curve. Technically, I think that it should be tangent on both of these curves. So like that's why we have the compensated budget line, is because it'll be tangent for B, because like I can't get two tangencies, because tangencies is just touching it at one point. It's like that's why we invented the compensated budget line. Technically, they should be like a little. It should look a little better. Like you can tell that this would be going down if I drew it perfectly. For like points, getting points on this FRQ, you can typically like fudge it and just say like, if you write to the side like I meant for this, like if you just clarify that they're supposed to be on the same indifference curve, then I think you'll typically skunk points that you will successfully obtain them. But that's probably the worst, is when your budget lines or something like they don't match up, or they don't satisfy what you're trying to satisfy using the chart. And then you're really sad, and you might have to nuke your question with like your eraser, and and then the question will take 2 hours, and then you're like, dude, ECON410 sucks. But that's an experience we've all had. We've all been there. But now that I think we're done with the homework, I'll just give a quick, I think word on the street is that you guys don't have to figure out the numbers this year. So if you did have to figure out the numbers, I would just like very much so use this help sheet. This help sheet is like 1-to-1 perfectly how I figured out how to do the numbers, and like is a very good teacher in my opinion. And maybe the numbers would help make sense as to why like the MRTs and the MRSs, like why the compensated budget line has the same slope, and like why stuff has to be on the same indifference curve. Mathematically it helps piece it together, but I think we've shifted away from that because we're a little behind this semester. And this is just a really good review. I would look at this if like what I just explained in the past 5 minutes didn't make sense, that it pretty well teaches you like the point of tangency thing that I just mentioned, why we have the budget, the compensated budget line, how to graph them. And I think it just does take practice. Like you have to make a few of these with different combinations of stuff happening to really like have it piece together and feel confident that you could replicate it on a test. But anyway, with that, I think we're good. It's still so dark. I feel like I don't know, it's like winter time. Like we're still in September, but it feels like outside it's like a sad day in January or something. But hopefully you learned something. I think I've learned something too. Going through these reviews always make me feel a little more confident in my own econ skills. Only an hour 10. That's not bad. We're still coming in at like the hour time. What's an interesting, I can tell you, your word of the day. I'm in Polish classes here. For anyone that doesn't know, my goal over the next year post-graduation is to move to Poland. And I'm in these Polish classes. I went to Poland this past summer. I did some learning. I'm still doing some learning. The Polish language is super hard and terrible and sad. But some of the words sound pretty funny and cool. And one of my favorite words means excellent. And how you say that is świetnie. And maybe I can even write it on the thing. Wait. Okay. I'll give you your word of the day. And maybe I can incorporate a word of the day because it's kind of cool. So if you're writing świetnie, that is spelt like this. So this little character, you just make a sh sound, and then V's turn into a V. And specifically in this word, it sounds like an F, but don't worry about that. And then I think for English speakers, you could figure that out, that it's just yetnie. Does excellent have 2 L's? I think it has 2 L's. That looks normal. I've been hopping between languages over the past 5 years, so my spelling in English has gotten really terrible. But that can be your Polish word of the day, is świetnie. And that means I'm doing excellent. Typically people ask how you're doing, and then you get to hit them with świetnie. And maybe you can apply that whenever you go to Poland. That can be your go-to. But I hope you guys enjoyed. I felt better about the energy today, and actually I had less cuts when I'm willing to flounder in front of the camera and not just like cut away all my mistakes. But I do wish you guys luck with the midterm. I know midterm 1 has a good amount of stresses. You don't really know what you're getting yourself into. But I just say, like, I don't know, really, if I were in your shoes, like, not to gas myself up, but I truly believe the homeworks are like the biggest piece of the puzzle. And if you rewatch some Fun with Foos episodes, you feel good about the homeworks, you have used your help sheets, you did a couple practice problems, I think you'll swim pretty nicely. I think you'll hit the swan dive right into into the questions on the exam, and I think you'll kill it. But I wish you guys the best. Hopefully, you're not too scared of what the future may hold. And just kill it. Make sure to get your beauty sleep. Make sure you're feeling good for this exam. But yeah, hopefully you guys enjoyed, and I'll see you next time. Bye.